Hello everyone, welcome to day 30 of Leetcode May challenge. Today we have question number 29, divide to integer. In this question they have given us two integers, dividend and divisor, and we have to divide two integer without using multiplication, division and mod operator. The integer division should truncate towards 0, which means losing its fractional part. And we have to return the quotient after dividing dividend by divisor. And the important thing to note over here is we have to assume that we are dealing with an environment that could only store integer within the 32-bit signed integer range. That is this. And for this problem, if the quotient is strictly greater than 2 to the power 31 minus 1, then we have to return an integer's maximum value. And if it is strictly less than minus 2 to the power 31, that is integer dot minimum value, then we have to return this. So in example 1, the dividend given to us is 10 and the divisor is 3. So after dividing them, we got the answer output as 3. In example 2, dividend is 7 and divisor is minus 3. So after dividing them, we got the answer minus 2. So let's see how can we do this. In this question, here I have taken dividend as 16 and divisor as 3, and we have to find the quotient, and dividend and divisor is given to us. So as we don't have to use any mod operation or any division operation, so we just can use addition or subtraction. So first way, if we are using subtraction, is if our divisor is 3 and our dividend is 16, we will subtract 3 from 16. This is one time we have subtracted, we got 13 as the remainder, and then again we have subtracted, we got 10 as the remainder. This is time we are subtracting them. Then we are subtracting 3 for the third time, we got 10, and then after we subtracted 3 from 10 minus 3 we got 7, 7 minus 3 we got 4, 4 minus 3 we got 1, and after 1 we cannot subtract. So if in this form if I could write, it would be 16 is equals to, we have divided it 5 times, so that is 5 into 3 and plus the remainder which we got, that was 1, and that we can return as the answer, that is quotient. But using this approach will increase our time complexity, because 16 is a smaller number, but what if the number is greater? So the operation it will perform will also be greater, so the time complexity will increase. So what is the optimal approach of solving it? So the optimal approach can be, instead of subtracting 3 every time from 16 and going on, we can just double the value. So if this is 16, if we can subtract 3 from 16, we will double the value, this is 6. If we can subtract 6 from 16, we will double the value, this is now 12. If we can subtract 16 from 12, we can double the value. Now this is, we have to subtract 16 from 24. So this is not possible, it will give us the negative value. So now as every time we were doubling, this was 1, then we double it, we got 6, then we double it, then we got 4. So every time we are doubling, then we double, we got 24. So every time we are doubling and finding out. So what we will do, till the time it will give us the negative value, we will stop over there and we will get a count, that is 4. We will store over here, and in the next iteration we will send the result, that is 16 minus 12. This is now 4. So now for 4 again we will iterate. So 4 again, if we can subtract 3 from 4, we will double. If we can subtract 6 from 4, no we cannot. So we will stop over here. So this is not possible. So now only at this stop we stop. So what is the count we can take? 1. So the previous count plus the count we got in this step, that is 1. So now we will again subtract 4 minus 3 and we will go to the next step. So it will give us the 1. Then we will check if we can subtract 3 from 1. No, this is not possible. So our count will be 5, and that what we will return as an output. Now the next thing is, we are done, let's code it up. So first thing is given to us is, if dividend, over here it was given that if quotient is strictly greater than this, if dividend is at its minimum value. Minimum means we are left shifting 131 times, and our divisor is -1, then we have to return integer maximum value. And here we will have this boolean which will tell us the sign. We already know, if like for the positive we have the sign positive, and for negative we have the sign negative, and if the sign is positive and negative we have the sign as negative, or if the sign is negative and positive then we have the sign negative. So if they have the different sign, the sign will change. So for here we will assign, if our dividend is greater than equals to 0, and that is equals to a divisor, if they have the common sign or the same sign, then this sign value will be true. Then this sign value will be true, otherwise it will be false. And now we got this, and we need the absolute value of our dividend and our divisor. So is equals to mat dot absolute of dividend, and so is equals to mat dot absolute of divisor. And then we will have one answer that will store our result or our count. Initially we will have this 0. This is our result which we will give, and we will check till the time our dividend minus divisor is greater than equals to 0. Our next step was, if this is greater, we will every time increase it by 2, and then we will see if this is still 4, then we will again, if it is greater than the divisor, then again we will perform the same operation till it becomes less than the divisor, and once it becomes the less, we will return the result. So first thing is we need count, that is 0, and we will have this other operation, if dividend minus divisor, left shift 1 and left shift the count. Why are we doing this? What this left shift operation means? So left shift operation mean, if our value was 3 for sake, that is 0 0 1 1, and we perform the one left shift operation, that is 0 1 1 0. So this was 3, and here it become 6, and again if we perform the left shift, it will become 0 0 1 1. So this is 12. So this is how, what we are doing, we are increasing, we are left shifting them and increasing their value. Twice we are doing these values. And how, and the count is like, if the count is 1, then we will left shift it by 1. If the count is 2, we will left shift by 2, we will get 6. If count is again increase, we will left shift it by 4. This particular value will be left shift by 4, and then we will get 12. So this is what we are doing, and that's why this code is for that. And if this is the case, we will increase the count. Initially the count will 0, so there will be no left shift, but then we will have 1, then we will have 1, like this it will go, and our result will have this one left shift count, and our dividend minus divisor and the count. And then we will check if our sign is true, then we will return result, else we will return result with a negative sign. It is this, it is not. So let's run this. Okay, boolean sign, what is where we went wrong? Okay, over here, this is this. Let's run this again. Okay, it is res. What is wrong with this? We have to return this. Same here, typo. Okay, so the time complexity is log n square n for this solution, and the space complexity is constant. Let's submit it. We are done.